right, thank you all for coming tonight. Appreciate it's not raining too much. So we're going to kind of dive in pretty quick. So just go over the agenda for today's talk. Talk about our goal, our problem, what stack we decided to use, the process, and the conclusion. So we have two people from Truly here who I'm working with. This is Vincent Lamb. He's one of the senior application developers. And this is Sonal Joshi, and she is the senior automation engineer at Truly. So she's the QA face, he's the dev face, and unfortunately I'm the ops face. So if you have questions, and you have questions from a different perspective, let us know. We went over that they're going to tell the truth no matter how much I ask them to lie. One of my favorite quotes is, "The problem well put is half solved." We'll kind of go through this the whole thing. But the goal that we initially got from management was we want to release more frequently. I mean, how many of you get this? We want to release all the time, right? Yes, there we go. A few hands. That's not really a goal that you can do, so we wanted to restate it as a solvable problem. Okay? We wanted to build a continuous delivery pipeline with a truly a mobile API that's usable for all stakeholders. We didn't want to build something that only QA could use, or the devs could use, or ops could use. It had to be something that was usable for everybody. Here's the problem from the dev side. I develop my code and it works fine, and when it goes to production, there's a problem. Right? There's no real visibility as to what's going on in production. Right? You know this problem probably better than anybody else, right? Troubleshooting is difficult. We spend a lot of time going back and forth about what's broken, how it's broken, who's going to fix it, right? And the ops team is not helpful. I am not helpful to you because you're a pain in the butt. Okay, the problem from the QA side is, hey, we tested it, right? I know I tested this, right? You see someone all smiling back there and shaking their head, yeah, we tested it, right? But it doesn't work in production, so, that's a little frustrating. They couldn't test multiple builds at the same time, right? They wanted to increase the pace. So if they're going to test one build, wait 3 days, and test another build, that's going to lengthen the pipeline, and nobody wants to be the long pole in the tent. And there was no shared communication between the dev and the ops team. So QA stuck in the middle. I don't speak ops. I speak some dev. Right? So how do I make sure that everybody knows exactly what needs to go on here? And again, the ops team is not helpful. The problem from the ops side. Okay? The dev and the stage environments were inconsistent. So there was a shared development server that everybody had full sudo access to. So surprisingly enough, certain packages got installed, nobody ever thought to mention it, or configurations got changed, or, hey, Vincent's working on something and he needs a new version of Redis, and now developer B comes in and, overwrites it with an older version of Redis, because that's what they're used to, and now we have problems. And the whole development pipeline slows down, people get fussy, right? The prod environment was just unreproducible, right? There were files being copied around in production, synced from different hosts, and keeping track of everything. And I'll go in a little more detail of what was getting synced around, but it made it really hard for us to audit and see what was going on in real time. And in my defense, the incoming requests for ops were a little bit difficult to parse because we didn't have a shared language. Right? So the problem restated is solvable. Right? We needed to build a common language. And that's a culture problem. We needed to build a reproducible environment. That's a tech problem. And we needed to provide automation and visibility tools. And that's a tech and a culture problem. It's tech in the sense that we build the tools, but it's culture in the fact that I convinced Vincent that the best way to view logs is Logstash. Or, hey, these are the graphs that you need in QA to figure out what's going on. So we had to build the tools and the trust to kind of get everybody together on the same tools. These are all the icons for all of the stack that we decided on. We'll go into detail what we use each one for and kind of why we chose it. Okay, so the first off, we chose Docker. A little bit buzzwordy at the time, so we started this. When did we start this project? Yeah.
Me?
Yeah, you helped me start it. So when did we start? We started it a year.
Right after the merge, so 2015.
2015. So we've been on this project for a bit. And at that time, Docker is the hot thing, but there were also some benefits to it that we decided. could definitely build a reproducible, immutable-ish platform. It can't be completely immutable, otherwise it's not useful for everybody. We needed to control the application dependencies. So now we have everything bundled together. We're sure that this unit works together, and it's easy for QA to QA, it's easy for devs to dev against, it's easy for us to troubleshoot. We needed automated build capabilities, and this was one of the big selling points of Docker. Zane gave a great talk about how we use Amazon. If you're building AMIs, it's a slow, long process. They'll try the patience of a saint in most cases. So we wanted something a little faster and to build a little cleaner. And instead of running 4 Vagrant boxes on a nice Mac Pro and just blowing the whole thing to a crawl, you can run several containers on a Mac Pro for a developer until you get problems with UDP buffers, and then you swear a lot. And the last is, this is a stateless application of your development. And this is really critical. Do not use Docker for stateful applications, you'll be very sorry. Right? So if it's going to come up and go away, perfect fit. Right? If you're mounting volumes and trying to save data, keep track of where your data was, there are new tools in Docker that are supposed to help you, but at this point, why add extra overhead on the MySQL database, right? It's just another step you're going to have to troubleshoot, make it more difficult. You probably already have a DBA who's like a rock star and can help you figure it out. And if you add another variable, it's just going to make it harder. So we decided to stay away from stateful applications in Docker. Does anybody currently run Docker in production? So, step 1 is we wanted to come up with a base image that developers could use to develop against. So, there's a GitHub repo, Shokunin. It's Docker Vagrant Puppet Project Generator, because I wanted to add as many letters as I could in my GitHub project. It also has a generator now for generating an AMI project. So, because we do both, we wanted to make it as easy as possible for someone to generate a new project, kind of in the way we have things set up.
What is AMI?
Oh, Amazon Machine Image. It's like a virtual image for that you deploy on Amazon. So to kind of go into that, so basically you bundle all your software and everything together in an Amazon Machine Image. You put it in what's called an auto-scaling group, because what happens to things that you run on Amazon? They die. And so the ASG will basically start up a new one when they fail. And so if your software is bundled together, it starts up, registers with a load balancer, and starts serving requests. At scale, you're going to lose anywhere between 5 and 20 Amazon images a week. Okay? So they just go away. So just get into, and same thing with Docker, just get into the idea that it's going to go away.
And what scale are you talking about?
That was 2,000 or so Amazon instances running. So yeah, we're losing anywhere between 5 and 20 a week.
Are you getting any whale notification from Amazon? Sometimes they send an email, hey, your instance could be...
Yeah, no, these are ones that just locked up. I know he's seen them lock up on occasion quite frequently. I've heard him swearing from across the room when we served together. But yeah, it happens. They lock up for no good reason. And the idea is it's a cattle, not a pet. So if you have a problem, just shoot it in the head, spin up another one. Don't waste any time on it. Don't give it a cute name. Don't take it to the bed, right? Just kill it and start up another one. Honestly, because you could spend days. If it's an endemic problem, you see it lots, like more than once, yeah, dig in. But otherwise, kill it. Fire up a new one, right? We used Puppet to build containers instead of Docker files. So if you've played with Docker, you'll see these Docker files. They're really easy to run. It'll take you about 10 seconds to build a Docker file and get it going. The problem with that is it's only good for Docker. And one of the kind of key components that we like to work is we want things to work in as many different environments as possible. At Trulia and other companies, they have very large Puppet infrastructures, and the ops team and some of the developers write their own Puppet modules. And so we found that we could reuse these modules from production and develop the development build images just as quickly. So it was a nice carryover. We build on Jenkins. How many people use Jenkins? Good. How many people like Jenkins? Yeah, that's a lot. That's hands, okay. We also...
2.0 is a big improvement.
2.0 is a big improvement. We haven't gotten there yet, so yeah, that is definitely on my list of things to do. And we also offer a Vagrant option. So this project generator will create a Vagrant file that will source those Puppet modules and build a Vagrant image. So if you want like rapid feedback quickly, if you're developing a new Puppet module or you're playing with some new software, Vagrant's a really good option for logging in interactively and playing with it. And when you're set and ready, good to go, fire off the Docker image and upload it. We tag with latest, and I'll go into why we do this horrendous thing later. And then we have a Docker registry. So we actually have a license for a Docker Trusted Registry from Docker, and that integrates with the LDAP and all this stuff for authentication, which now we don't use. So kind of defeats the purpose, but you can run them anywhere. You can run an S3-backed Docker registry in the cloud if you want, and there are all kinds of different options. You don't specifically have to go with that. Step 2, the developers need to develop locally. And while we are rethinking this assumption now for the current application, I think for most applications, the developer would like to fire up their laptop with their preferred IDE and get immediate feedback. We create separate run directories per environment. So we have Terraform Stage and Terraform Local. So we're using Terraform to spin up the Docker container. And the reason why we do this is we use Terraform for AWS. And we are not just spinning up Docker containers. So there's Docker Compose where you can spin up containers. It's kind of limited. It doesn't interact with other components. So we do a lot with console. And so this interfaces with console nicely. And so we can do everything at once. Yes?
The yellow pages, we use Terraform for all environments.
Yeah.
We use one file for each. And we don't have to have different ones. Because that allows differences to creep in.
Yeah. Well, we have to have differences because what runs on a developer's laptop is all of the supporting bits are in production, but they're not going to be, and I'll show you, when I show you the differences, I think it'll make sense. And then we have these console shared. So we have certain settings that are the same in prod, development, and stage. So we put them in a shared file. So when you turn on the hero image, like for example today, you change it in one place, it changes in every environment. And those environment-specific settings for things like upstream API key, or which ActiveMQ we're pulling to get our data from. So these things are going to change per environment. Okay, so the local Terraform, and this is why this is different. So we have a variable for the Docker connection because on Mac and for the Windows people and for the Linux people, this is all different. So we have to have a separate configuration for each one. We just source in the module with our shared keys, and we have these the run locations where we set like the data center or the data path. And I'll go into kind of what that is. So the run location has specific information. So for example, it says, grab this Docker image base mobile API and keep locally false. So what happens is when you run Terraform, it will check, it will always download the latest image. So that way when the developers are sitting there, I don't have to call up every single developer and say, hey, can you please pull the latest Docker image? It happens automatically every time. For the console master and the Redis, so because they're going to run console on their local machine, and they're also going to run Redis on their local machine for caching, those are all kept locally true because they almost never update. So that's one of the reasons why we have the difference, because now they're going to run the services that they need to develop locally as well.
A lot of other stuff, we isolate our developers from production entirely. They cannot access production data.
So we don't do that.
Let's just say the first time
Yeah.
one of our developers completely hacked our database.
I've had that happen before, but fortunately, Vincent is very helpful.
We live or die on
Yeah.
our database.
That's scary. we were dissing Hadoop earlier today. And then this is more of the local run. So basically, we run this up, and in Docker, you can only run process. So what process do we run? Supervisor to run other processes. Right? We expose the ports. So now port 8080 is now visible to the local machine, and you can open up your web browser and go to 8080. It goes to 80 on the local Docker image, and you can serve up your data. We link to the other containers, and what this does is this allows them to resolve the other containers on the local box. So now they just type Redis API, and it actually adds a host file entry, and so that they can reach that container and pull data in and out of Redis. And we set a bunch of environment variables. So all of our Apache configurations in this case, because this is a legacy application, all the Apache configurations read these Apache run group environment variables and whatnot, and then use those to log or make settings. So for example, we're using the npm prefork, and that can be an environment variable. We set it, obviously we set the same default, but we can up that with an environment variable if we need to. And when we show you how it runs in production, it'll make sense. And then probably the most important thing are these two volumes down here. And var www, which is, hey, the Apache document root. And Docker logs are now visible on the local host. So when Vincent fires this up, that var data path that he says he runs Windows, she runs Mac, I run Linux, we all set them differently. Now he can write code directly into that environment, and it is sourced from the Docker container, and in real time they can develop their application and make changes. And then the logs are put in Docker logs. So if they want to look at their Apache logs for their PHP, you don't have PHP errors, right? No. Yeah. So that way they can look at any error logs and kind of figure out what's going on in real time when they develop it. So the mount volumes is a neat trick. Just don't do it in production because it'll come back to haunt you. All of our configuration is done in console. And the reason why we do all our configuration in console is that this now makes it easy to change quickly. So one of the things that we use it for is a feature flag. So I want to turn on a feature. It's very easy to turn across the whole infrastructure in about a tenth of a second. And there's a little web form for people who aren't too good at like Terraform or whatever, but it's very easy to change, turn on ludicrously. It's literally one line and it goes out everywhere almost instantaneously. So if you don't use console, I definitely recommend it for configurations.
If it's going to let's say you change something in console.
Yes.
How does it get delivered to your instances?
So what happens is, one of the processes we are running under supervisor is what's called console template. And it makes a connection to console and it registers a watcher for either a service or a key value. And in this case, these are all key value stores. So when that key value changes, it takes the template file, writes out the file you tell it, and then runs any Unix command that you want. And that Unix command for most of our stuff, because we're running PHP, is being true. But in the case of some of the node, I know, it's great, isn't it? Well, I put it in there. You don't need it in there, but I put it in there so it's obvious that you run a command after this happens. And so what we do for some of the Node.js applications is we reload the configuration file. And another nice feature of console is they have what's called a distributed lock. So you could have one machine lock, run the update, recycle the Node.js application so that it picks up the new configuration, pass the health check, and when that's done, it releases the lock, and all the other machines scramble to get the lock, and you can go through your environment that way and do like a rolling restart. So we do that. Dana's not here, because he set that up for a couple of Node.js applications. And so we definitely do that, just using console, not with Docker, but when we roll out Docker applications, they actually roll out and show you the config, how that works.
What does that give you over Puppet, Chris?
So Puppet is really good for saying, set this up this way and eventually get that way. And console is like now. Like my 8-year-old, everything has to be now, right? And so you just, it goes out, you can't even, if you're on the machine, you can't even cap the file fast enough if you make the change. It just goes out everywhere, you're sure that it's right, it doesn't converge over time, so it's really good for doing things really quickly. More orchestration than configuration management, I guess I'd say. And so,
Kubernetes cluster.
yeah, something similar. And so we have this null resource, which is kind of a fun trick that Zane taught me, that we just wait for this container to come up before we do all the settings. So I just put that in because that's a good Zane trick. And so what we do is we have the console template running, and this app name that's set here, we create Etsy truly app name.json. And so all the configuration goes into this file based on the app name. It's the same place for every application with its own app name. And it's really easy for the developers to find. It's really easy for ops to audit. And we have a nice, way of figuring out what's what pretty quick. So this was running on my local machine. I fired it up. It takes, if you're on the local network near the Docker Trusted Registry, it literally takes 30 seconds to fire everything up. Right, so you have everything coming up real quick. So you can see that I have var www in the containers mounted. I create this PHP info file. There are all my console settings, and there's the actual PHP. So it's very easy to kind of develop locally and go. I mean, it starts up fairly quick. And we'll go into some of the problems with it. Some of the annoying stuff. Okay, how did I get to 3? All right, so the next step of kind of working this together now, we're getting into QA land. So Sonal's going to smile a little bit. Right, so we decided to create a build pipeline. We're using older Jenkins. I know in Jenkins 2, pipelines are first-class citizens.
Workflows are even better.
Workflows are even better? Okay, I hope, because they're pretty crappy now. So basically, what we do is, this is our build pipeline. And when it goes green all the way, Sonal smiles. When it's red somewhere, Sonal gets angry and calls me and says what's going on here. And we sort it out. Quick aside on Jenkins, right? We configure Jenkins with Puppet. So what's going to happen in a large organization is every group's going to get their own Jenkins, and it turns into a pet. They take care of it, they take it to the vet, and it's going to die one day. And then you've got a lot of trouble. Because who put in what job? Oh my God, what packages do we have installed? We did it all by hand, it's not a Puppet. Rebuilding the Jenkins server can take a week. Yeah? So there's a nice plugin called SCM Sync that I definitely recommend. If you run Jenkins anywhere, and if you learn anything today, install SCM Sync. What it does is it takes your configuration and it puts it into Git. So if somebody changes a job, that's saved in Git. Right? If your machine goes down, you pull down the repo from Git, and you have all your jobs back. Right? We keep our Jenkins boxes as vanilla as possible for most people. Some people sitting in that row right now might not have vanilla
You
Jenkins.
need that with workflows.
Yeah, because they're in the repo, right?
No. Once you have it in a workflow,
Yeah.
you can actually do upgrades in your Jenkins.
It's not upgrades that are the problem. The problem is that the Jenkins server dies,
Even if it dies,
the disk starts smoking.
the workflow just keeps running.
If the disk is on fire?
Yeah, it keeps running, letting you bring up a new instance. They actually designed it to do that.
Well, we keep them as vanilla as possible for this reason. And, oh yeah, we configured them with Puppet. I just said it twice because it's really important. So one of the features that Jenkins provides, I don't know if you've ever seen the little thing that says, show me all the environment variables that are, those environment variables are very useful. Mainly the build number. So whenever Jenkins kicks off a build, it has an environment variable called the build number, right? This is now our shared key. So our language all revolves around what build, what container is it, and what build is it. Now we all have a common touchstone instead of latest, or git tag foo, or what's on server B. So now we're all talking the same language. Right? Hey, Sonal's like, it's not passing. She talks to Vincent. Hey, this container, this build failed to pass the smoke tests. Can you please look at this class foo that's thrown in there? Oh, easy for him to figure out what's going on real quick. Cut out all of the communication problems that we've been having in the past. Hey, she calls me and says, hey, build 12 is having trouble communicating to the user database. That's something you can action right away. I don't know, if you're on an ops team, you see the ticket, like I have no idea what this ticket is. That ticket makes sense, I'll work on that one first, right? We're trying to eliminate that and make it as easy as possible for us to identify a solvable problem. And ops of the dev team, hey, we rolled this container build out 12, and we noticed that this KPI time doubled. That's pretty easy for them to start figuring out where to go look. We did a breakdown of some of the tickets we did, and we found that 80% of the time was going back and forth trying to figure out what was going on. Do a lot of people find the same thing? Like, actually fixing the problem once you figure out what it is not hard, but going back and forth to figure out what the QA person is talking about and why the ops guy is babbling about subnets is, you spend a lot of time on that. And so we're trying to shrink that time, because that's now, after all the automation, that's now the largest amount of time that we spend fixing problems. And the most frustrating, right? When nobody knows what anybody's talking about. So, we package our software, right, as a Debian container. Or, sorry, as a Debian package. This used to be really difficult and take a lot of time, and a lot of cursing, and a lot of upset. This is no longer the case with FPM. Okay? We push it to Apply, which is a Debian package repository that has an API. And somebody wrote a really good CLI tool to access the API sitting right there, so you can bug him if you don't get it. And so we push her to this package repo that we have. Now we have an artifact that we can download and take a look at. If it's a tarball, you have no tools to determine the versioning, right? Except for the file name of the tarball, you can change files inside. You have no idea. Packages as Debian. It's going to save you so much trouble. You can go using ncollective or a shell script and go through thousands of machines and get the package installed and know with 100% certainty what is there. There are no questions. So removing all of that ambiguity makes everybody's life a whole lot easier. This is the package.
Mac then?
Huh?
Linux, what about a Mac?
You can pack. I think does FPM do Mac package? No, I don't think so. But you can package stuff on Macs if you need to. But if there's Chocolatey for Windows, I do know that. So if you need to build a package, right? This is the packaging script. It is really simple, right? We CD into the build, which is mounted. So we have the code on Jenkins. The build container, right? We run a separate container that mounts this container, runs Composer, right? Which is really great. The developers spend a lot of time using Composer to pull down all of the different PHP packages that they needed. We rsync this into a directory, and then this is the FPM command to create a package. It's one line. That's not very hard. Now we have an artifact that we know. And look, we use the environment build number. So now we can go back and figure out which Jenkins build tree. We can tag that Git. We can tag Git with that build number so then they can go back to the code. We don't do that, unfortunately. But in other places I have done it where that build number gets tagged back into the Git, and then you can find the exact version of code that's running. But now you have one point where everybody can agree that that build number is what I need to know to get everything done. Then we upload the Debian package to our little repos, 3 curl calls, and we clean up after ourselves like good citizens. That's it. That's really all there is to creating a package now that is in our Apply repo forever. It's a version that we can find, and then we can run all these different commands that we need to figure out what it is. It's not that hard. Really. But thank you, Dave. Okay, next in the pipeline, we take that base container that we all work so hard on, and we slap on the package. And we're done. That's it. We upload this to our Docker registry, and we tag it with a build number so that we know what it is, and we're good to go. We have an artifact that we can deploy to production. Docker tags. Be super careful with latest. Anything that goes into production should have a build number tag. This will make your life a lot easier trying to figure out what latest is. The only reason we tag latest is for the base AMI so the developers don't have to keep track of them. But in production, anything we keep track of. Okay?
And never pull latest.
Never pull latest, right, for anything in production. And we'll show you how we pull the versions going forward. But yeah, it seems easy until you got to figure out which containers run. Okay, the next step in the pipeline is we run in QA TCD. TCD is truly a continuous deployment. It sounds really fancy, but it's the QA environment, that's Sonal's backyard. So we take that container with that build number, and we spin it up in the Nomad cluster. We run Terraform to update all of our configurations, and we set up our database credentials using Vault. Vault is a tool from HashiCorp for storing secrets. So for example, your database passwords, your user credentials can all be in Vault. It's auditable. You can have passwords change all the time. So there's a lot of really cool features in Vault. We use it on like a very base level. We went to the first thing and then everybody said we got to do Vault because it was really cool. And it has been very useful for us keeping track of credentials, who uses credentials, what credentials we need, right? And now your container is available from the load balancer as TCD Mobile API 10, build number, qa-tcd.example.com. So we can all go around and curl or show little shots from our web browsers as to what's going on. And she can QA more than one thing at a time. So it has this really nice features for everybody. We like it.
So when I say run console there on the configuration console,
Yep.
you will run this in shell or you have Jenkins job?
Jenkins, this is all through Jenkins jobs. Yeah, we don't do anything by hand. Next, we run the deploy test. So one of the things that in Docker you're going to find is that health checks now become something that's really critical to have a good health check. Right? Because you have these services moving around all over the place. You need to have a quick and easy way to find that they're healthy enough to handle traffic. So Consul also does health checks. So it checks the service to make sure it's healthy before it puts it in the rotation so that it's visible. Right? And some of these health checks can hit like 20 times a second. Right? You got 5 load balancers, you got 3 console checks, you got monitoring going on. So there's a lot of hits to these. So if it's slash and it's a really slow page, you're going to basically take your container out of the load balancer because it's going to fall over from load. Right? So we keep this as light as possible. The basic things we need to serve. One of the engineers, Vinay came up with a really good idea of a deploy test, where we do all kinds of stuff, where we hit Redis to make sure that we can connect to it. We make sure that we can access all the databases. We make sure that we have all these configuration files. This test is really heavy, right? But we run it because it has more details. And so we only run it occasionally, right? So that one we might hit if there's a problem, knowing that it's heavier, but it's not getting hit 20 times a second. So this was a really good idea. And so this is what we run. We run a deploy test. Did it come up in the Nomad environment? Does it pass the deploy test? Good. Then we can move on to the next thing. Smoke test. And this is awesome. Now you understand. We call another Jenkins server that she runs, where she has a lot of tests, a metric truckload of tests, I believe, yes. And so we call her Jenkins. We pass it the build number, and it knows to go to that host. And she runs a huge number of tests that run really quickly and are awesome and catch a lot of stuff. Right? Once the smoke test passed, we go ahead and we have what we call the repointer job. So because this is for the application doesn't allow you to choose different hosts. You couldn't put in, on your app, put in TCP mode, you have 10 up, it'd be a pain in the neck. So we have like stable and unstable. Right? And so what this does is this updates the repointer job such that unstable is now the build that just passed the smoke test. So it makes it easier dealing with external people. Kind of just like, this is what you point at to do your tests, and we'll let you know when it updates. And we still have the information. What we do is that build number now gets set as an HTTP header. So that if you curl anything, there's a little HTTP header that says, hey, I'm version whatever. So we can find out at any time. And that's a trick that the QA people use, that we use. Sometimes we forget what's on production and just do the curl just to remind ourselves. But it does some sanity checking to make sure that that build is actually running before it goes ahead and does the repoint. And again, this is just a Jenkins form. There are forms, and then they're passed along as part of the build as a pipeline plugin. The next steps, we have our pre-prod environment. And we push our configuration live at this point. Right? I repeat this every time we push our configuration live at this point. Right? We run a single container with a newer version that has a different alias that now they can hit external people can hit, and we can do some in-depth check, right? So that we know for sure that the code works in production with these settings. So we used to take one out of the load balancer and redirect some traffic. None. Now we have a separate container that we can hit and ensure that whatever bug we're fixing is good. A lot of times they might just send that over to the product person and say, hey, look, see, it's working here. Right? We're going to roll it out. And then you do run some other tests on pre-prod too, right? A more evolved test suite. So now Sonal has a very high degree of confidence that this code, this configuration set is going to get her what she needs to get things out in production. And again, it's just a form, Jenkins, put in the build number, go. Finally, the release to production. There's another form where they put in the build number, it checks to make sure that's what's running on pre-prod, and it goes ahead and releases that to production. And I'll show you how that's done. And the containers are rolled out with the sleeping concurrences. I mean, that's it. This is what she does. She fills in the build number, and clicks build, and it's out in pre-prod, and the problem's the same. This could all be done automatically as part of a Jenkins pipeline. We are just building up confidence as we go along and building up our test set even more so that we know for sure. Hopefully someday we can just be that it just goes all the way through and maybe send an email, congratulations or something. All that just for a push button deploy. Isn't that amazing? Okay, so once things have been deployed, there are KPIs and various dashboards that we have that are up on the wall. They change colors and look nice, and so we can see what's going on. Or a lot of times what happens is we'll look at the wall and go, oh yeah, they released the production today. Oh, okay, everything looks good. Okay. We're not involved in the ops team, right? QA, the devs, and the product managers make the decision to push live or roll back. Some of the internals. So we use Nomad. There's Kubernetes. There are a few, there is the Amazon one that caused an outage the other day. We chose Nomad for a couple of reasons. One is it's not limited to Docker. Again, when in doubt, most flexible tool wins. It integrates nicely with Consul. I believe Kubernetes uses Consul, can use Consul as well. We are in love with Consul. It is great. It's easy to set up. It's a single binary. Done. Right? And there's the same configuration. This is kind of what it looks like in our QATCD. We have our client. We have Traefik, which is our HTTP load balancer, and it points to these Docker containers running in different places. They all register with Consul and say, hey, I'm available here at this dynamic port number. Go ahead and add me to the load balancer. And they're automatically added to the load balancer, and based on that host name, we do the route and figure out where to go. The Nomad configuration is, I said it was simple, maybe not. But we have our job. Our job name is builds. Right? So this is a little tool that we wrote so that we can keep track of what's pointing to what and what git tag it came from. Right? And to build a service to run in Docker took 2 hours. Right? Little API, little GUI in Sinatra. Okay, 1 hour was trying to remember the configuration for backup in Sinatra, and the other hour was building code deployment. So it was very fast to build a service that people could use right away. Right? We have update, so stagger 10 seconds with a max parallel of 2. So that means that if the container version changes, do 2 at a time, sleep 10 seconds between every one. We've already rolled it out to pre-prod, so we have a very high degree of certainty there. The group, we have run 10 containers. So there are 3 kinds of jobs in Nomad. There is a cron job where you can spin up a container every morning at 3 a.m. and run this job. There are system jobs that say, hey, run this container on every single Nomad node in my cluster. And then there are just regular jobs where you say, give me 10 of these. How many times to retry? These are the defaults I just put them into. See them? Then the driver is Docker. So tomorrow, if we write a Go application, we can just run the Go application in no container. We don't have to do anything. You should run a straight up binary or a Java jar. You can just run a Java jar. So it does make a lot of sense moving. You can have these different ways of running things. You don't necessarily need a Docker container. We're saying, hey, run McGUC pointer build 5. So that's where the build number comes in. Right? That's the number. So when we basically update this file, we change the build number. It's a little template. change the build number, and then it registers that something has changed, and it goes ahead and does the rollout of the stagger, right? And now we say, hey, map port 9292 dynamic. So we don't use static ports. So you can have these dynamic ports. And then we say, register this service with the tag web service. Find this dynamic port and register it in console with this health check. Hit / every 10 seconds to make sure that this is healthy. So, and then it will register with a load balancer. And we set some environment variables, like, oh, point at this console server, do this, do that, do the other thing. And then we can set some resource limits on the job. So say you have a team you don't like. You don't want to give them resources because they don't buy beer for your team. You set them up with lower resources. These are soft limits, so that until there is a resource contention on the box, it doesn't come into effect. So they're C-group limits. So we decided on Traefik as our HTTP routing layer. We used HA proxy pretty heavily. So one of the problems with HA proxy is restarting it frequently. Doesn't really like that so much. It doesn't like go file handles, you get stuck, you have all these problems. So we decided to move to Traefik, which can basically watches the file, stats the file changes, reloads the file, and can route HTTP requests very quickly. So we have 40, 50 containers coming up and down really fast, and HA proxy couldn't keep up. So the newer version of HA proxy supposedly has some more dynamic configuration abilities, but yeah, we put this in source or is that open source? Open source. Open source. The only thing we pay for is Docker Trusted Registry. Everything else is open source. It's one single Go binary. The guy that wrote it's really helpful if you open an issue, and for the most part, it does what we want. It can read straight from etcd, Zookeeper, or console. It just doesn't do everything that we want, so we actually use this templating language in console template. We say, if the tag contains web service, right? So we tag that service that we registered as web service. We go through and we generate the backend with the address and the port. So we generate all these backends with the address and the ports that we can go to. And then we generate the front end. We match on the name. Ooh, this is actually wrong. Sorry. There should be 2 slashes here in front of that. That's something we found today. But basically, if it contains the web service tag, we go ahead and we create these backends. And then we say, watch this console key services HA proxy redirects. And in there, we have the stable key. And if that changes, it creates a route from the stable to the backend that we put in there. So that's how we do the repointing. We basically change the console key, and then it changes the configuration of the load balancer, and then the requests get routed there right away. So it's got a nice little quick front end that we use sometimes to troubleshoot. These are your routes, where things are going. So you'll see that we register the server name as the IP address and the port. So that it's a little more dynamic. We don't have to worry about it. And you can see that we set these backends. We're using round robin. And then this is the real-time dashboard where it gives you the average response time, which seems really high. I don't think it's that high. But you can watch your 500 errors if you want. But you notice we don't get a lot of those. That's from a whole day. The downsides of Traefik, there's 2. One is that it holds onto file handles, so that when you do a log rotate, you have to hop the process. And when you do that, the counters reset. So you come in the morning, oh my god, it crashed! And it takes you a little while to realize that. So that was not good. I had a small heart attack. I come in every morning, I'm like, oh my god, it keeps crashing, what's going on? And then I figured out that's what was going on. And the other thing is, in the Go language, HTTP headers are case insensitive. So they camel case them. They don't leave them alone. They camel case them. It's a key feature of the language. So if you have case-sensitive HTTP headers, you're going to have an issue, right? Those are the 2 issues that I found so far. I can pretty much live with both of them compared to all the trouble we had restarting HA proxy whenever we needed to. And certainly better than the F5 load balancer. Vault and console template. So we generate configuration values like I showed you from the key store. And we use it for feature flags, and we store database credentials. So for example, the mobile API connects to 35 different databases. Right? We have, I think, 100 and something DB handles all over. We call DB handles a credential pair set And so keeping track of all these is like a really difficult. And so we have them all in one place, so if we change a password, it's changed everywhere. Or if we change something, they're all in Console and Vault, so that we change them everywhere. And now we have them listed. So you can't go copying files around to Docker containers, because you never know what IP they're on, what port they're listening to. They have no SSH. So you have to generate these files, and we use Console and Vault to do that. Logging. Now containers come up and down as whimsical as possible. So you can't log in and look at the logs after it dies. Or you restart it, or you replace it. Or somebody says, hey, let's go back last month and see how many impressions we did. It's gone. This was a big challenge for us. And the reason for that was there was some legacy code, and we had to go through and agree on this is the name that we're going to give to the path of the logging directory. We need to go through the code and find any hard-coded log paths and sort them all out, and all of the modules that we call need to do this as well. So this turned into a major undertaking. And the dev team was initially like, how are we going to do this? And then I think once we started putting them in Logstash where they could visualize them really easily, they were, oh, okay, yeah, cool, yeah, let's do that. So they were really helpful. You guys spent a lot of time on that. Yeah. And so that was a big ask from my side, and they were really accommodating, and that really helped everybody out. So we built enough confidence at this point, so now that we're talking the same language, and we can make things happen, and the unreasonable seeming request from me was actually, oh yeah, that makes sense, we can do that, yeah, that's a good idea. Okay, so all of the Apache Nginx logs now include the container, the app name, and the build number, so that when we roll out, we can see the changes, because the build numbers are in the logs. So that allows us to track things back. Traefik also has a unique request ID header that you can pass along so that you can trace it back through all your logs. HAProxy has one as well. If you use either one, it's nice. At one company, we modified the ORM to add that unique request ID to the MySQL slow logs. So you can trace the slow query generated by the ORM, and we have no idea where it comes from, to a web request to an error log. And therefore, we can figure out where all the slow queries are. So that's a really nice feature of Traefik and HAProxy. So definitely recommend it. All of the application logs are in JSON format. If you deal with a lot of different logs, and say somebody adds an extra space to the log file, and your little script that parses them out breaks, you know how much time that takes to figure out the changes. So if you log in JSON, really easy to add new fields, really easy to parse them out. We fingerprint our stack traces, which is another nice feature of Logstash. You can take a certain part of the log and run a SHA-256 on it. Take out any identifying information on the user ID. So we fingerprint the errors together so that we can cluster them together nicely. And Nomad creates these dynamic allocation directories. And we log to those, and we pick up the logs from them, and we rotate it out. Or we send them to syslog-ng for our friend here, and he picks them out and does what he needs to do with them. So this is an example of our dashboard. We have, hey, this is the container, this is the build number. These are the methods, this is the duration. So now you can go and say, hey, find me all post requests that took longer than 2 seconds. That's a powerful tool for developers right away. Right? And we pass around these Logstash dashboards. So you can create a temporary dashboard and you pass around the link. And what happens is, oh, I need to move that down further, or move it up, or do some different searches. And so this is our language for communicating errors now. We send the Logstash dashboard with the errors that are visible. You can look at them and go, I know exactly what that is. Or I can look and go, oh man, I can't hit the Redis server. I know exactly what's going on. And we fix them much faster. We have this now shared language of the Logstash dashboard where we can go back and forth and sort things out. This is what our stack traces look like. You can see all these SHA sums, right? You can query down a specific SHA to figure out what's going on. And you can see that we did a release and something went wrong. Because the number of errors increased. Now we can drill down and see exactly which error increased, and then we can go back and talk about it and figure out what's going on. So we also have lots of information in here on the user agent. So Vincent and I sat down to build out, hey, this is how many iPhone app requests we get. This is how many Android apps requests we get. These are the versions of the application that people are using. So now this is really useful information for them. It's like, do we really have to support this one over here, right? Or can we find out who's using that and get them off of it? Right? It's even worse if you deal with hardware. Remember, we offer to upgrade certain people who had an old device. It's like, just stop using it, because we have to keep all this infrastructure in place to support this whole thing. And so you want to get people cycled through eventually, so that everybody's on a more supportable version. Another things that we worked in, so our KPI was released more quickly, right? That's great, but Vincent and I and Sanal, we like numbers and graphs, right? So we pull all this database, this information off of the logs, and we send it to StatsD with Grafana front end. We pick up the actual container level stats with cAdvisor, so we know how much CPU is being used by each container. And so we have a really good idea of, hey, the app v1 Google Now endpoint. Remember I showed you earlier that endpoint slowed down. We have a good idea of what's going on. So we map all these to stats. We have the upper and lower performance values. And so we have a lot of visibility into what's going on. We didn't have this before. Right? Now this allowed us to basically drill in to grab all these stats. Right? This is the CPU usage of all the different containers. So we can see if one container is acting wonky, way out of line with the others. We have the network, we have the average memory usage, and we have some Apache performance data. So now we can drill, if one container is acting wonky, we kill it. And we let Nomad spawn another one. Right? We haven't run into that. I haven't seen a wonky container yet. We also allow the devs, they can SSH into the Nomad nodes, connect to the containers, and debug in real time. And you might think letting developers connect things in production is a bad idea. Not if it's a Docker container. Because we have the agreement, do what you want, do what you need to do, we're logging everything, do what you need to do, and then kill it. Right? If you make any changes to the container, you kill it. A new one gets spawned, and we're good to go. It's all audited, and now, because we have a great language that we all can communicate in, and we have trust built over time, that it becomes easier for everyone to accept this. Yes, it is a little bit of a pain in the neck to go through all the Vault SSH to log in, but it's possible if you need to do it, and kind of trust each other enough now that it's not an issue. There are no silver bullets, right? We always agree that there's trade-offs when we're doing technology. One is if you're running the unit tests on your local machine, it's slow. It's got to connect to 35 different databases that are in a data center far away, right? There's an initial learning curve. If you're running a Mac, the Docker tools spin up a VM, and then they run the containers inside this VM. Right? So now you have to troubleshoot the VM and the Docker containers, right? We've had issues where with the VPN. So if you spin up on your Mac, you're connected to the VPN, you spin up your Docker container or your Docker virtual machine for the containers. It sets the resolve.conf, and then if you turn off the VPN, it's still stuck to the old one, and you've got to restart the whole thing. And people get upset. It's kind of annoying. The little GUI tools are nice, but they are difficult, and there are hidden problems there that you have to work on. Docker on anything other than Linux, in my opinion, is pretty painful. I mean, he runs Windows, he made it work, but he put a lot of work into making it work. Okay? The apps need to be modified. We ask for logging changes, we ask for configurations. Hey, you got to read a JSON configuration file, right? And the developers, you know, that's extra work. We're asking you to do something that's extra work. So we got to present it in a way that's useful, right? So you can't take your application, just throw it on Docker or AWS or Google Compute Engine and expect it to work the same. There have to be changes made. And there's a little bit of control given up. So everybody has control. We let you log into production. It's a little bit harder for you to do things, right? Some of the improvements that we can make going forward, even better troubleshooting tools, right? So what's connecting to what? What's getting information from where? This is the problem that Giants Company is working on. This is a hard problem when you have all these containers scattered all over the world, connecting to AWS or some third party. So that's something that we need to work on. So a shared Docker host. We have like one host that runs Docker that they can SSH into from anywhere, and for things that are heavily upstream dependent. Right? More local services. So like a new application where you have only one database and ORM database fixtures. Right? We'd run the MySQL on your laptop. So you have everything you need on your laptop. You don't have to worry about the VPN, you don't have to worry about any of that other stuff. But like I said, this application is legacy, it connects to a whole bunch of different places. So anything newer, a Rails app, a Node.js app that has a single, Redis and a MySQL, and that's pretty easy to develop locally on the desktop. Better training and support for desktop Docker issues, and these are all of the tricks with the VMs and your Macs and all these things. More cool libraries, like one of the developers was really helpful. He wrote a thing called Monologue that formats everything in JSON. And everybody just imports Monologue, and they're good to go. So we need more tools like that, more libraries that are reusable in all our different applications so that we can collect stats and data and make things setting up easier, like the project generator that I have. We need to make it as easy as possible to overcome those initial hurdles. That's pretty much it. I wanted to thank Kevin again. Thank you very much, Kevin. Appreciate you guys hosting us. Thanks to Sonal and Vincent for coming. And she's working on all this. And Pam as well, because she worked on it for about 6 months with us. So if you have any questions, does anybody have any questions? Yep.
So pipeline, so I'm going to experiment with the role-based offers, and I named Jenkins plugin thing. The role-based authentication plugin, I'm trying to get it to work with the pipeline way of doing things. And somebody desperately wants the ability to have a step in a pipeline that's authorized only like a release manager kind of a role.
You do that, right? Zane, you have the checkboxes in your deployments for... So in our case, what we do is those are actual